Hello and welcome. I am Unhelkar, and it's my privilege to take you through this very important module chapter that deals with actors, use cases, and use case diagrams. Now, more than 3 decades ago, when I wrote my first COBOL program, it was more like write the program and let the user figure out how best to use the output. It was very solution centric approach to putting a good piece of software together. In fact, even design, which is a part of the solution space, which will become the MOSS, model of solution space, was minimal. And there was no concept as such of MOPS, or model of problem space. So now that we know the OO fundamentals, we can understand what's an object, what's a class. We are aware of the 14 UML diagrams. Shouldn't we start designing our solution? Not yet. At least for this and the next chapter, we are still going deeper into building model of problem space. We don't build the entire model here because it's really the job of a business analyst, the one who is specializing in requirements modeling, to do that. But for you and I, we will still create a rough sketch of the requirements and then go and do a good software design. So in that sense, to be able to produce a quality piece of software, what we do in this and the next module are equally important. So what is it that is the key starting point for understanding the requirements of a good solution? Obviously, it is the person or the role that the person is playing, for whose benefit we are writing our software. It could be a teller in a branch of a bank, a passenger flying an airline, a patient registering herself in a hospital, or a traveler checking into a hotel. I just gave you the examples of actors. In UML, the actor is an excellent starting point for doing requirements or building the problem space. What is the role? What goals the role wants to achieve through the software is this starting point. And then how it will achieve, through which steps, which alternate steps, where there is a straight flow, where there is a variation in the flow, all that is documented in what is called a use case. So a use case describes the way an actor uses the system, the solution that we are designing. So obviously it is an actor does something and the system, the solution responds with something else. I enter my user ID and the system responds saying enter your password. I provide my account details and the system comes back saying how much amount would you like to withdraw. There can be interaction between two actors as well. And all the actors are outside the system boundary, you and I, and our corresponding interfaces through which we interact with the system. If we look at that definition, which you can read in the chapter, we suddenly discover all external interfaces are also actors. And funnily, even time, which initiates a transaction, print a report at 12 o'clock night, is an actor. So you will find variations in actor. You can abstract the actor. All staff in this university will have a login. They will have a login use case. But I could be playing the role of a teacher and someone else that of an administrator. There will be variation. Also remember that an actor customer and a class customer, which we are going to discuss in the third or fourth module from now, are different. One is a interface and the other is details about that particular customer. Very fine differences, very important differences. And finally, we put it all together. We put all the use cases which are represented by ellipses and the actors, we put them on a diagram, which is called a use case diagram. In the previous chapter, we had a brief chat about organizing our project, and I said we will organize the project through packages. So each package can have a use case diagram or two, made up of a few actors and a few use cases. But when you put the diagram together, you will learn another interesting thing. You can extend a use case or you can include a use case. Don't go too deep into it. That's still in the problem space, modular problem space, where you can add notes to your diagram to explain what you mean. For example, customer deposits cash and customer withdraws cash in a bank can both include customer identifies herself. So inclusion allows us to put reuse up in the problem space. Similarly, extensions are specializations. So a customer identifies himself, 4 different specialization, through an ATM card, through a voice activated message, through hand scan, passwords. So those are the things that you're going to study in this chapter. Please read the chapter carefully, look at the discussion questions, and of course start applying it in your project work. I hope you are enjoying the course as much as I am. Stay in touch. Take care. Bye bye.